Okay, so in this video we're going to talk about the energy that goes into breaking and making bonds. So when you have two atoms get together, they are attracted to each other. Well, the nucleus of one is attracted to the outer electrons of the other. Well, they will start to move closer and closer together because of that attraction, but as they move closer and closer together, you have two nuclei coming into contact. So those two nuclei start to repel each other. Well, the distance that the atoms end up sitting from each other when they make a bond is going to be the bond length, and that's going to be the distance that stabilizes that repulsion of the two nuclei. So as you have atoms that are attracted to each other, they move closer together, and this attraction creates some stability. It lowers potential energy. Well, as they continue to move closer, the nuclei repel each other, and potential energy starts to increase again. And then eventually they move in a distance that will stabilize those repulsions, and that's going to be the bond length. And the potential energy at that point is going to be the amount of strength that the bond has. So when you have a bond, and we're looking at strength, the more electrons that are involved in that bond, the stronger the bond is. So if you have a triple bond, that's going to be very strong. That's going to be stronger than a double, which is also stronger than a single bond. So, shorter bonds also tend to be stronger than longer ones. So if it gave you the bond length, you could actually compare the strength. So if you know that you have two atoms that are closer together, that bond will be stronger than two atoms that are separated by more distance. So bond dissociation energy is the strength of the bond. It's the same thing. So if you see that, you know that they're talking about the strength of the bond, because that's how much energy it takes to separate the two atoms. So if I'm looking at this, an H2 molecule, I can separate those atoms, and it would take 436 kilojoules. So if I take CH4, what I could do is I could take off one atom at a time and get the bond dissociation energy, which is relatively close for each one, except for the last one. And basically, they take the average for those bonds to get the bond dissociation energy. All right, so for bonds, when we break a bond, we actually have to put energy into that process. That's going to be an endothermic process. It takes energy to remove the atoms from each other. When we actually make a bond, energy is released during that process, and that's an exothermic process because it releases energy when you create that bond. And if you think about it, when you put two atoms together, if it lowers the potential energy, that energy has to go somewhere, so it gets released. So the energy change in the whole reaction is calculated this way. You can take the sum of the bonds that you break, and then you subtract it from the bonds that you make. And then overall, depending on whether this is negative or positive, it tells you if the reaction itself is endothermic or exo. Okay, so this is just a table of some bond energies. You don't have to memorize these. You'll be given these on the test, and some either reference sheet or in the problem. Okay, I will let you read this yourself, but just to remind you, when we do this process, when we go through this, we're actually going to have to draw the molecules out. So just as a reminder, this is the general rules for bonding. So when we have organic compounds, carbon will always make 4 total bonds. Hydrogen usually bonds once, oxygen likes to bond 2 times, N 3 times, sulfur twice, and then also halogens bond once. So bromine, iodine, chlorine, all of those in group 7A bond once typically. All right, so we're going to calculate the bond or the energy released in this reaction. All right, so first thing, we have to draw out each of the molecules. So when you see a compound written like this, it's telling you how the molecule itself is structured. So when I see CH3, that means the C at the end of the molecule will be bonded to 3 hydrogens. So I should have 3 hydrogens like this. And then we go to the next carbon. There should be a carbon there. And it tells me that there's a 1H bonded to it. And then this double line here indicates there's a double bond. And then there's 2 more hydrogens at the end. So let's just check, make sure we've got 4 bonds for each carbon. 1, 2, 3, 4, 1, 2, 3, 4, and then 1, 2, 3, 4 for this one. All right, so now we're going to go to the next molecule, H2. Well, hydrogen only bonds once. And then when we look at this, we have carbon, it's bonded to 3 hydrogens. And the next one is bonded to 2. And then there's one at the end bonded to 3. All right, so now what we do is we're going to count the bonds. So we need to identify what type of bonds we have on the reactant side and the product side. So here I have a CH bond right there. I also have a single bond between the 2 carbons. And then between these 2 carbons, I have a double bond. All right, so, and then I also have an HH bond here. So also note, I'm not counting this as a single bond as well, it's just a double bond here. All right, so if I go and I look up how much is each one worth, and you can do that on this table right here, so you should be looking at your notes for that. If I look up a CH bond, it's 412 kilojoules per mole. And we need to count how many of those I have. So I have 1 here, 2 here, 3, 4, 5, 6. I have 6 of those. Okay, for CC, I have 1 of those, and each one is 348. And my CC bond is 612, and I've only got 1 of those. And then my HH bond, I have 436 kilojoules, and I've got 1 of those as well. All right, so let's multiply these out. Oops. 436, okay. Okay, so now we're going to add these up together. We do this so that we can get the total amount of energy required to break all of these bonds. Because these are reactants, we have to break the bonds in order to make new bonds. So it's going to be 3,868. All right, so now let's look at the product side. Well, we have CH bonds, and we have single bonds right here between the carbon atoms. So for CH, each one is 412. And I've got 1, 2, 3, 4, 5, 6, 7, 8. So if I multiply that out, I get 3,296. Ooh, can't really read that. So that's 3,296. All right, so for the CC bonds, that's 348, and I've got 2 of those. When I multiply those out together, I get 696, so this plus this will give me okay, so I have 3,992 kilojoules released when I make all of these bonds. So to find the total energy involved in this reaction, I will take products, I will take reactants minus products. and I should get negative 1,240 kilojoules. Jeez. Okay. So this reaction is exothermic altogether because it releases 124 kilojoules when I make this compound and I break all these bonds. All right, so let's look at another one. Okay, so let's look at this. Draw the molecule first. So you've got 3 hydrogens bonded here to a carbon, double bond here, and plus another bromine molecule. And then right here I have a carbon bonded to 2 hydrogens and also a bromine. Bromine cannot be in the center of the molecule because it can only bond once, so it has to be on the outside somewhere. All right, so now I go to the next carbon. It's bonded to a hydrogen, and again, bromine cannot be in the center of the chain. It can only bond once, so it has to be attached to a carbon on the outside. All right, so then I have one more carbon, and it's bonded to 3 hydrogens here. All right, so now I'm going to count my bonds. I have a CH bond, I have a single bond between the 2 carbons here, and I have a double bond here. I also have a BR bond here. All right, so now let's look at our data. Okay, so for CH bonds, that's going to be 412 if I look it up. And there's 6 of those. So that's going to be 2,472. Now for CC bonds, that's 348. I have 1 of those. For a CC bond, that's 612. And I've got 1 of those. And then for my bromine bond, I have 193, and I've only got 1 of those. All right, add everything together, 3,625. All right, so now let's look at the product. So we've got CH bonds, we've also got a CC bonds, and CBr bonds. Well, for this, it's 412, and I've got 6 of those. So that's 2,472. Okay, for CC bonds, that's 348, and I've got 2 of those. So that's 696. And CBr bonds, I've got 1 and 2 of those, and that's going to be 76 times 2. All right, so now add them together. All right, so now we've got the total for the bonds being broken, and then the total for the bonds being created. So now we take reactants minus products. Get negative 95 kilojoules. So that means this was also an exothermic process because I am releasing 95 kilojoules. One more example. All right, so we're going to draw everything out. This one's slightly different because not all the coefficients are 1 here, so you have to draw every molecule out because you're trying to count all the bonds. So, okay, for CH4, it should just look like this. And for chlorine, we've got 2 of those. Well, chlorine only bonds once, and we've got 2 of those, so I have to draw each one out. All right, let's look. The next one is fluorine. Only bonds once, it's a halogen, but I've got 2 of those. All right, so now let's look at this. carbons in the center because it likes to make 4 bonds, and it has 2 fluorines and 2 chlorines attached to it. It does not matter where they go. All right, now I've got HF. Both of those only bond once, but I've got 2 of them. And HCl. Only once for each one. Hydrogen likes to bond once, and so do the halogens, but I've got 2 of those. All right, so now do the same thing. Figure out which bonds you have and how many. So I have a CH bond. I have an FF bond. And I have a CL bond. Well, let's count. I've got 1, 2, 3, 4 of those, and each one is 412. So that's 1648. All right, so FF is 154, and I've got 1, 2 of those. So that's 308. Chlorine, well, that would be 293 or 239. And I've got 2 of those. So now add them together, 2,434. All right, now we're gonna do our products. All right, so we have CF bonds, CCl bonds, and HF bonds, and HCl bonds. So that's going to be 485 times 2. We have CCl, which is 339, and there's 2 of those. HF, I've got 2 of those, and each one is 565. All right, and then HCl, we've got 427. I've got 2 of those. That's 854. Okay, so all of these added together, 3,632. All right, so now to get the total, bonds broken minus bonds formed, and we get negative, again, kilojoules. So it's exothermic again, it releases energy, and that will conclude what we do in this video.